everyone. Mathematics is the gate and key of the science. Neglect of mathematics works injury to all knowledge, since one who is ignorant of it cannot know the other science or the things of this world. In your textbook, take page number 156. Learning adjectives. Sum rule, product rule, inclusion-exclusion principle. Combinatorics and mathematical induction. Now let us learn a basic counting principle which happens to be the highlight of this chapter and is an important concept, so please concentrate. Sum rule. Let us consider two tasks which need to be completed. If the first task can be completed in m different ways and the second in n different ways, and if this cannot be performed simultaneously, then there are m plus n ways of doing either task. This is the sum rule of counting. Next case, product rule. Let us suppose that a task comprises of two procedures. If the first procedure can be completed in m different ways and the second procedure can be done in n different ways after the first procedure is done, then the total number of ways of completing the task is m into n. Now I will explain how to find sum and product rule with the help of example. Assume I am walking into a restaurant that sells pizzas and burgers. There are 4 different types of pizzas and 3 different types of burgers, and I plan to eat one item only, whether pizza or burger. So I have 4 varieties to choose from pizza or 3 varieties from burger. So in total I can order one of these 7 items, one of these 4 plus 3, 7 items. Let me now change this problem. I decided to buy myself one pizza and one burger. Okay, it's not just one item but 2 items. But I am sure I'll be buying one pizza and one burger. In how many ways can I make my order? First option, one pizza, one burger. That is first pizza and first burger. First pizza, second burger. Possible a second option. First pizza, third burger, third option. Similarly, second pizza, first burger. Second pizza, second burger. Second pizza, third burger. So on and so forth. So in how many ways I can make my order? Clearly it is 4 times 3, which is equal to 12. Please remember, last time it was 4 plus 3. Last time it was 4 plus 3, that is 7. This time 4 into 3 is equal to 12. So it is only commonsensical to know when to add and when to multiply. Previous case was addition, this case was multiplication. Previous case we have OR. If you have OR, we have to add it. If you have AND, then we have to multiply. This goes by the title rule of sum and rule of product. The inclusion-exclusion principle. Suppose 2 tasks A and B can be performed simultaneously. Let n of A and n of B represents the number of ways of performing the task A and B independent of each other. Also, let n of A intersection B be the number of ways of performing the two tasks simultaneously. We cannot use the sum rule to count the number of ways of performing one of the tasks, as that could lead to overcounting. To obtain the correct number of ways, we add the number of ways of performing each of the two tasks and then subtract the number of ways of doing both the tasks simultaneously. This method is referred to as the principle of inclusion-exclusion. Using the notations of set theory, we write it as n of A union B equal to n of A plus n of B minus n of A intersection B. In order to count the number of elements in the union of two sets A and B, we need to know the number of items in set A, number of items in set B, and the number of items in both A and B, that is intersection of A and B. Simply adding the elements in A and B together will count the elements in the intersection twice. So, we need to subtract the intersection of A and B in order to obtain the correct number of elements in the union of A and B. This concept can be stated using the mathematical formula, that is n of A union B equal to n of A plus n of B minus n of A intersection B.
Math puzzle is a good exercise for your thinking skill. Now, I am going to test your thinking skill. Rule for this puzzle is draw 9 dots as shown. Your task is to go through all the dots using only 4 straight lines. The next line has to start where the last one ended. For example, now I am going to draw lines from this dot. So I will get like this: second straight line, next third straight line, then fourth straight line. Now one dot is remaining. So this method is wrong. Okay, try this. At the end of the session, I will explain the answer for this puzzle. Now we are going to see example sum. Example 4.1. Suppose one girl or one boy has to be selected for a competition from a class comprising 17 boys and 29 girls. In how many different ways can this selection be made? Here we have number of boys 17, number of girls 29. We need to select one girl or one boy. Option is R. If we have R option, then we need to add boys and girls. We can select one boy in 17 ways and we can select one girl in 29 ways. So 17 plus 29 is equal to 46. Here the main concept is R. If we have R option, we need to add. If we have AND option, then we need to multiply. Example 4.2. Consider 3 cities: Chennai, Tirchi and Tirunelveli. In order to reach Tirunelveli from Chennai, one has to pass through Trichy. There are 2 roads connecting Chennai with Trichy and there are 3 roads connecting Trichy with Tirunelveli. What are the total number of ways of travelling from Chennai to Tirunelveli? There are 2 roads connecting Chennai to Tirchi. Let us name them R1 and R2. Further, there are 3 roads connecting Trichy to Tirunelveli. Let us name them as S1, S2 and S3. Suppose a person choose R1 to travel from Chennai to Trichy and may further choose any one of the three roads S1, S2 or S3 to travel from Trichy to Tirunelveli. Thus the possible road choice are R1, S1, R1, S2, R1, S3. Similarly, if the person choose R2 to travel from Chennai to Trichy, the choices could be R2, S1, R2, S2, R3, S3. So, there are two roads connecting with Chennai with Trichy. And Trichy to Tirunelveli, three roads. Here we have the option as AND. If we have AND option, then we need to multiply. 2 into 3 is 6. 6 ways of traveling from Chennai to Tirunelveli. Here we need to use only the option is AND. We cannot use OR option. Example 4.3. A woman wants to select one silk saree and one Sungadi saree from a textile shop located at Kanchipuram. In that shop, there are 20 different varieties of silk sarees and 8 different varieties of Sungadi sarees. In how many ways she can select her sarees? Silk sarees. Number of silk saree is 20. Sungadi sarees 8. The work is done when she selects one silk saree and one Sungadi saree. Here the option is AND. If we have AND option, then we need to multiply silk sarees and Sungadi sarees. The woman can select a silk saree in 20 ways and Sungadi sarees in 8 ways. By the rule of product, total number of ways is equal to 20 into 8. Since we have option is AND, we need to multiply. 20 into 8 is 160. The total number of ways of selecting these two sarees is 160 ways. Example 4.4. In a village, out of the total number of people, 80% of the people own coconut groves and 65% of the people own paddy fields. What is the minimum percentage of people own both? Let N of C denote the percentage of people who own the coconut groves and N of P denote the percentage of people who own the paddy fields. Given N of C equal to 80%, N of P is 65%. By the rule of inclusion-exclusion, N of C intersection P equal to N of C plus N of P minus N of C union P. The maximum value of N of C union P is 100. Therefore, the minimum value of N of C intersection P equal to N of C is 80 plus N of P is 65 minus N of C union P is 100. 80 plus 65 is 145 minus 100. 145 minus 100 is 45. 45 is the minimum percentage of people who own both. Now, I am going to solve this problem with the help of Venn diagram. Minimum percentage of people. Minimum percentage of people is nothing but n of C intersection P. Assume that as X. C denote the coconut groves. Consider two intersecting circles. The first circle denote coconut groves. Coconut grove is 80%. Now only we are going to find this part. So this full part is 80. This full circle is 80. Now I am going to find the remaining part 80 minus X. The second circle is paddy field. Is given as 65. Now I am going to find only this part. Then we get 65 minus X. Now I am going to add these three. Then we get 80 minus X plus 65 minus X, which is equal to maximum value of C and P is C union P is 100. Minus X and plus X will be cancelled. 80 plus 65 minus X equal to 100. 80 plus 65 is 145 minus X equal to 100. Then X equal to 145 minus 100, that is X equal to 45. That is X is nothing but n of C intersection P, which is equal to 45%. That is minimum percentage of people own both is 45%. Example 4.5. Find the number of strings of length 4 which can be formed using the letters of the word bird B-I-R-D without repetition of the letters. The condition is without repetition. Given strings of length 4. So we have divided into 4. Then we have 4 elements. We need to use the letter B-I-R-D. The condition is without repetition. There are as many strings as filling the 4 vacant places by the 4 letters. Keeping in mind that repetition is not allowed. The first place can be filled in 4 different ways by any one of the letters B, I, R, D. So suppose I have taken R, then I will have the remaining 3 letters, following which the second place can be filled in by any one of the remaining letters. The remaining letters is B, I, D in 3 different ways. So for example, I have taken D. Then I have the remaining letter is B and I. Following, the third place can be filled in 2 different ways. The third place can be filled in 2 different ways. For example, I have taken I. The remaining letter is B. Then the following 4th place can be filled in 1 way. That is B. So 4 into 3 into 2 into 1. The number of ways in which the 4 places can be filled by the rule of product. That is 4 into 3 into 2 into 1 equal to 24. Hence, the required number of strings. The required number of strings. The required number of strings is 24. Example 4.6. There are 10 bulbs in a room. Each one of them can be operated independently. Find the number of ways in which the room can be illuminated. Each of the 10 bulbs are operated independently. Consider B1, B2, B3, B4, B5, B6, B7, B8, B9, B10. Each bulb can be operated in 2 ways. That is off mode or on mode. The total number of ways doing this is 2 power 10. 2 into 2 into 2. Each bulb has 2 options. then total number of ways of doing this is 2 power 10, which includes the case in which 10 bulbs are off. Keeping all 10 bulbs in off mode, the room cannot be illuminated. So we get only one option. Then hence total number of ways. Hence the total number of ways. Number of ways are 2 power 10 minus 1. 2 power 10 is equal to 1024. That is 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 30 times 2 is 64. 64 times 2 is 128. 128 into 2 is 256. 256 into 2 is 512. 512 into 2 is 1024 minus 1. Here keeping all 10 bulbs in off mode, the room cannot be illuminated. So we get only 1024 minus 1. So we get only one option. 1024 minus 1 is 1023. Example 4.7. Find the total number of outcomes when 5 coins are tossed once. When a coin is tossed, the outcomes are in two ways, which are head or tail. Each coin has two options. Each coin has two options. By the rule of product, the number of outcomes when 5 coins are tossed is 2 into 2 into 2 into 2 into 2. That is 2 power 5. 2 power 5 is equal to 32. More generally, if n coins are tossed, the number of outcomes is 2 power n. Now, if 7 coins are tossed means then we get 2 power 7. Now, if 3 coins are tossed once means then we get 2 power 3. So, more generally, if n coins are tossed, then the number of outcome is 2 power n. Did anybody solve this puzzle? Now, I am going to join these dots by using only 4 straight lines without lifting my hand. So, join these 3 dots and extend the line. And join these 2 dots, and again you have to come like this and you have to end this way. Okay, this is the correct method. Wow, that absolutely astonishing. Thank you, students. Practice all the problems and do the given homework. We'll meet you in the next session.